Hello, 8th graders. So today we're going to be continuing going over our exponent laws. So the next rule that we have to learn is called the powers rule. So write this down under powers rule. Pause the video if you need to. When you raise an exponent to another power, blank the exponents. We're going to figure out what you have to do here. So let's look at the first example. In the first example, we have 4 squared, so we have an exponent, the 2 next to the 4, raised to the third power. So you have an exponent being raised to another power. In order to figure out what I need to do in this problem, I'm going to expand it. So I'm going to follow order of operations and expand inside my parentheses. So I have 4 times 4. But I still have that cubed. So I now need to write this expression how many times if it's cubed? Right, I need to write it 3 times. So 4, expand it out 3 times. So now how many 4s in total do I have? Right, I will have 6 4s, so I have 4 to the 6th power. So if this is the same as 4 to the 6th power, what do I need to do to my exponents? Do I add them, subtract them, divide them, multiply them? Right, when I raise an exponent to another power, I need to multiply the exponents. Make sure you have that all written down, and then I'll try another one with you guys. For example 2, we have 5 raised to the 3rd power and then raised to the 4th power. If I look over my rule, I know I have an exponent or a base raised to an exponent and then raised to another power, so I can multiply my exponents. So I have 5 raised to 3 times 4, which is the same as 5 to the 12th power.
Surprise! Okay, hi! Since some of you think that I can't teach science, I'm going to prove that I can actually teach a little bit of math. So I'm going to go through our product rule first. Our product rule is when you multiply exponents with the same base, add the exponents. So we're going to take a second and write that down. Pause the video if you need to. And then our first example. Our first example is -6 to the 2nd times -6 to the 2nd. So what I have to check first is, do I have the same base? Yep, I have the same base. So my base stays the same. But if I have the same base, what do I do with the exponents? I have to add the exponents. So I add 2 plus 2 means that this is -6 to the 4th. Let's try one more. Our second example, 5 to the 6th times 5 to the 4th. Do I have the same base? Yes, my base is 5. So my base stays the same. But what do I do with my exponents? I add the exponents. So 6 plus 4 is 5 to the 10th.
Yay, Miss Mac!
See, I can teach other subjects. God, this video.
All right, so now we're going to move on to our third and final rule, our quotient rule. So in our quotient rule, we are doing it when we are dividing exponents. So write down the quotient rule. When you divide exponents, because quotient means the answer to a division problem, so when you divide exponents with the same base, subtract the exponents. So pause the video, write that down, and now we're going to go over the 2 examples. All right, so our first example has 8 to the 5th over 8 to the -2. What does that fraction bar mean? Right, that fraction bar means division. So I am dividing, so we're going to use our quotient rule. So now I'm going to do 8 to the 5th power minus -2. If you remember how to do integers, go ahead and do it. If not, just plug this into your calculator the way that we learned how to plug integers into our calculator. So 5 minus -2 is 7, so this is the same as 8 to the 7th power. Now let's try the second example. This example looks different, but is it division? Yes, so we can use our quotient rule. Do we have the same base in these 2 numbers? Yes, we do. Our base is 4, so we can subtract our exponents. 8 minus 2 will give us 6. So our final answer is 4 to the 6th power. All right, go ahead and finish up the bottom of your worksheets where it says simplify the following expressions using the rules. And then also go on to the back of the worksheet and do that page as well. Stop once you get to the guided practice. We are going to do that part together. Good luck.